So in this scenario, we receive as input an array of string, and then in that array of string, we are supposed to construct the longest string chain respecting a given condition. And the condition here is that any consecutive element should respect the condition of being a predecessor. And then here we have defined the predecessor of an element valuable if we can add any character to the previous element to obtain the next character. What does that mean exactly? That means if you have a character maybe like this A, B, C, a valid possible next element will be an element consisting of A, B, C in the same order plus any character of your choice, exactly one. For example, you can see that ABC is a predecessor of ABAC. Why? Because if you take this, you can add A here after the B, and then you will have this. Whereas this is not a predecessor of this. Why? Because no matter what you do here, no matter the character you want to add here, you will never reach here without you rearranging this input. So that is why this cannot be a predecessor of this. So now, given that, how are we going to solve this? What will be our approach of solving this? The first approach I will use is it will look like this. So I will take my input, which is an array of words. The first thing I will do is that I will sort the array, and after sorting the array, I will loop through each of the elements of the array and then compute the number, in fact compute the chain ending at that character. And by doing so, I will be able to have the longest chain at the end. We are going to have the first thing we sorted our array, you remember. So we are going to do this. We are going to sort our array based on their size. After sorting the array based on their size, we are going to loop through the words, and for each of the words, we are going to say, okay, your size is initially 0 for the word, and then we are going to loop through the length of the word. We are going to create a subsequence of that word minus one character, and since we are looping using I, we are going to remove the character at the position I, and then the longest will actually be the maximum of longest and count of the sub plus 1. That means, okay, the sub character that we obtain by removing the character at position I plus 1 would act like the longest of that at that position. Now each of those positions will actually give any longest, and then we need to return the maximum. That's why we use the max here. Now at the end of this one will contain the longest substring, in fact the longest chain ending at that word, and then we just say, okay, the count of that word will be longest, and then at the end we just return the result. In fact, for each of the operation, the result will take the max of the longest and the previous max. That means whenever we are computing the size of each of the longest chain ending at a given word, we need to store it, and then we return the maximum. Let us run this and see what it gives. So perfect, this one is working, but it is working. We have everything green, but this is actually taking up to 170 seconds. And then why is it taking that much time? The first thing we can optimize here is the sort. We know that the sort is big of n log of n, but in this scenario, the sort we are doing can be easily achieving by using, I would say, a kind of like the counting sort, where you just count, where you sort element based on their occurrence. So what you can do is that for each of the element, you can create a map where you store the element corresponding of that length. So for instance, if I have this array, this one will go to the key of 4 because it is size 4. This one will go to key of 1 because it is size 1, and so on. And then after doing this, now you can loop through your keys and just append those elements. So that means if you have an array like this, in fact you have something like this, you have something like 1, we have this, 2, we have this, 3, we have this, and 4, we have this, and at the end you loop through your keys, and then you just take this, you concat to do it to this, to this, to this, and then you have the result. So you can optimize your sorting approach and leave the same logic behind here, and then by just doing this, you are going to optimize your algorithm. Let us run and see what it gives now. So by doing this, we're able to move from 170 to 141, which is already good. It's not bad, it's already good. But now, one heavy thing here is this. You do agree with me that creating a substring, every time you are looping through a string is actually heavy. This is actually heavy. So the next approach will be, how can you optimize this? So to optimize this, we are going to think of this solution. So the solution will be like this. What I will do is that I will create a dictionary of words based on their occurrence. So I'll have something like this. Now, after having something like this, what I will do is that I will loop through each of the elements of my dictionary. For each of the elements in my dictionary, I will say, can you be a successor of any of the elements in the array of length u minus 1. By doing so, you avoid creating a substring of each of the elements you are looping through. What does that mean? Is that means, okay, I will loop through my element, I will say, okay, this, I will have BA. This BA, we actually loop only in the array of element of size 1, because it cannot be a successor of element that is not different, that is not 1, right? And the same for here, element of size 4 can only be a successor of element of size 3. So whenever you are going to find an element of a given length, you are going to loop through element of that length minus 1 to find if you can have a predecessor. And by doing so, you are still going to use the map to kind of store the occurrence while you are moving. So you have something like this. You say you have another map. You have a map that will be used as the count, and then you have a map that will be used as the group. The group is what we did previously. So you are going to group the element by size. Once you have grouped the element by size, you will now loop through each of the element. I mean, like each set of the element. This is maybe the first one. The element of the first size, it can be size 1, size 2, depending on the input. Now that first element, you are going to loop through each word of that element. That means, okay, you are going to loop through your dictionary, and then for in the dictionary, you are going to take the first occurrence, which will be this, and then for this, you are going to loop through each of the elements. So this is where we are. So you loop through each of the elements. For each of the word, you will now say, okay, the longest is actually 1, is actually that word. In fact, you will now loop through the sub possible word. Like I just said, the sub possible word of a given element is actually the list of words with the size minus 1. So the sub possible element of this element will actually be this element. I don't know if it makes sense for you. So the sub possible element of element at position 3 will be element at position 2. So by doing so, you loop through the sub possible element, and then you just need to check if it can be a pred. Why do you still have to check? Because the fact that I have a size, the fact that we have one character left doesn't ensure me that we can be predecessor. In fact, I can be a successor, or you can be my predecessor. That is why you need to have a helper function here that is going to compute, that's going to check if the two string can form a chain by just respecting what has been said here. And if it is possible, then yeah, you will say the longest now will take the maximum of the previous longest we had plus the count of the sub word. That means the longest ending at that sub word plus 1. And then by doing so, at the end, you just have the longest. So the idea behind is almost the same, in the sense of you compute the longest ending at a given position, you store it, and then you move until you go to the end of the array. But just that in this specific scenario, what we are doing is that we kind of reduce the area of element we are looping through based on the fact that, okay, an element can form a chain with another element only if they have one character difference. So that is the idea we are going to use here. So let us submit this and see what it gives. So we can see that this one is really more interesting than the previous one, in the sense of being 99.0%, 99.00% of C++ user. So I even had a solution bidding more than this. So this is my thought process of optimizing my approach. I hope you do enjoy it. Feel free to leave me a message in the comment section. I'll be really happy to interact with you regarding this. See you on the next video. Don't forget to like, subscribe, share. Ciao.